So let's start with this one. Show that a²+b² is greater than or equal to 2ab. And I guess like before you start the algebra and stuff, like think about it intuitively if you think this makes sense. Like, is this always going to be bigger than or equal to, is this expression here always going to be bigger than or equal to this one? And you can like think about examples, right? Like, I don't know, 2 and 5. So 2 squared plus 5 squared. That's going to be a pretty big number. It's going to be 29 compared to 2 times 2 times 5. Yeah, right. Like, obviously, if they're giving you a question to prove which is true, like you know it's going to be true, but it's always good to like get an idea of what the question's actually asking at the very least, right? So what are your strategies? Your strategies are, the first two are probably like your default ones. You want to see if you can do these in this situation, right? So let's have a go. Put everything to one side, take the left-hand side minus the right-hand side. And only do that like because here we're trying to show that this is bigger than this, yeah? Okay, so it depends on which way the inequality is written. It is very cool, yeah. Sorry, the maths will hit you well. It's okay. So here you go. Left-hand side minus right-hand side. So the important thing to do is that this is a statement that is required to be proved, right? We haven't proven this yet. So you can't actually use this, just like with your induction and stuff. You can't actually use this statement yet, right? We're not assuming it's true or anything. We can just interact with certain sides. So if we do the left-hand side minus the right-hand side, I'm not making a claim about that. I'm just doing that as an operation, right? With the goal of showing that this is going to be bigger than or equal to 0. Yeah? Okay. Can you see what we're going to do?
No. Oh, yeah.
Yeah?
It looks very familiar.
It does look very familiar. And this is probably something we need to be, expect to see at least, that perfect squares are going to be a key at this. Because this is a perfect square, right? How can you factorize it?
A minus?
Yeah? A minus b all squared. Why is that useful? Go back to the second statement. Squares can't be negative, right? So the key thing here is that, hey, this thing is always going to be positive because we're squaring that whole expression. This will always be greater than or equal to 0, right? When are they equal to 0? Well, if a and b are the same value, for example.
You can't actually just go up there and move it.
You can't, and that's very important, right? Because if you go up here and move it, like you're saying that this is already true. Right? Does that make sense why that's important? Like you can't just say, yeah, subtract 2ab from both sides, because you already have the inequality. Like you'll have the answer there. It's kind of cheating in some sense, right? It's cheating because we're required to prove that. So you can never use the thing that you're required to prove. But it's very subtle. It looks very similar, but all I'm doing is I'm doing the left-hand side and taking away the right-hand side. Right? And I get left with an expression. I'm not making a claim about that. I'm just using it, right? But when I get to this step, I can make a statement about it. I know this is always greater than or equal to 0, right? Cool. Jot that down for me.
This is going to be a hard topic.